We have our car cam script, but it's not assigned to anything. It doesn't really matter what it's assigned to. Let's assign it to our car just for sanity. And now when we scroll down here, you see the car cam wants to know which camera should track which object. And there's two ways to do this. The one that I like is to drag here from the hierarchy main camera onto where it says use camera, and it fills in that slot with the camera information from that object. Now for track object, it wants to transform, and I could drag car all onto it. Instead, I'm going to click on this mark next to it, which gives me a list of everything that has a transform, all the things that I could have dragged onto it, and I can select car all, double click that, and it fills in with the transform of car all. And so now when I drive around, the camera is constantly following the car, which is kind of a nicer camera than either of our previous ones that we tried out. There's other ways we could control the camera to switch between camera modes. I'll include the source for that in the final version, but I'm not going to show you here. Let's add more hills though. So I'm going to duplicate the hill. Again, that's Control D. I also want to say that just like there's this green arrow we can drag up and down with, there's a green square which allows us to drag it perpendicular to that axis, which in the case of our hills is a really handy way to keep them flush with the ground while we change their dimensions. We can have some bigger hills and some smaller hills, some longer hills. Duplicate these two, rotate them. There's really no harm in them overlapping as long as it's kind of the shapes that you want. 1.5, 2, there we go. And now when I drive my car around on them, you can see it bumps around, pushes its way over a bit. Oh, the car toppled over again. And we can still drive, you know, that could be dealt with another way. But we want to give the car a way to reorient itself when it gets flipped, kind of like the Warthog from Halo. Before we do that, let's do a little bit of cleanup. We have these spheres floating around. Let's call those each hill. Actually, I'm going to select all three. Name them all hill at the same time. And we already have a ground object. Let's make them children of the ground object, just for keeping organized. There. Inside of our car driver script, we want to add a new key to reorient the car. Let's make that the X key. We know it's going to look a lot like the previous one, so we can copy and paste for our check line. Except now instead of get key, we're going to use a different function. We're going to use get key down. And the difference here is that whereas get key triggers every frame the key is held, get key down only does it the first frame that the key has been pushed. Because we don't want to do this constantly, we just want it to happen once when the key goes down. And we're going to do several things to the car when the X key is pressed. Transform.position plus equals vector3.up. This will lift the car 1 unit off the ground. We're using vector3.up because it's an objective up vector. If we added instead transform.up, it would be up from relative to the car. So if the car's on its side, this could be, you know, east or west, depending on which way the car is rolled over, or it could even be down if the car's upside down. But by adding vector3.up, it's an objective up vector that'll always be away from the ground. We're going to do rigidbody.velocity equals vector3.0. And this will stop movement of the car, so that if it's in the middle of tumbling, it will stop its lateral movement. And related to if it's tumbling is we're going to set the angular velocity to vector3.0. This will prevent it from rolling. Otherwise, when we reorient it, it could keep having that roll component. And then lastly, we're going to do one that's going to be a little fancier looking. Transform.rotation equals quaternion dot look rotation transform dot forward vector3 dot up. I broke line here just for my low resolution editor that I'm using for the camera capture. You don't have to worry about breaking line there if you want this all one line. Transform forward is telling it the direction to maintain for the way the car should be pointed. Vector3.up is telling it which vector to make upright. And so this is going to make our car sit upright. Otherwise, all we'd be doing would be bumping a meter into the air and zeroing its spin and movement. But this is the part that really does work of setting the vehicle straight. If we try it now, we can press play. And if I flip the car over on its side, this is always hardest when I have to, there we go. Oh, I'm upside down, that's great. Now when I press X, pop, you can see the car is upright again. So if I mess up the car and I press X, boink, then it's good again. Now quaternions are kind of a complicated subject. They're important since otherwise there are problems that emerge from using yaw, pitch, and roll, something called gimbal lock if you want to search for it. The thing about quaternions though is even though they're very complicated from a math perspective, as programmers in Unity we don't actually have to understand them so much as we have to know what it is that we can do with them. And so for that you can actually just look at the autocomplete for quaternion, and you'll see there's all kinds of interesting things to read the documentation about how to use, but they're very powerful, very handy, and as long as you know what functions to call, it's actually not the end of the world if you aren't the kind of mathematician that knows exactly how to do those things, say on paper, or to write the code that makes them work. Now if the car falls off the edge of the world, that's still a problem, because we can upright the car if it flips, but if the car drives off the edge of the world, it's just gone. There's no saving it. I mean, you could keep tapping the upright button, and you can still drive in the air. But let's pretend like that doesn't work, because, you know, that shouldn't, and we should fix that on a day when we have more time. So instead, let's make it so that if the car goes below a certain point, it will respawn at a given location. So let's create two new public variables, each of them a transform because we want a position. Lowest ground object, this is the indication of when the car has gone too low. And the other public transform will be respawn position. This will be where we'll set the car when we've caught that it goes too low. Let's do this inside update. We care each frame whether this has happened. If the car's transform position vertically, or y, is less than the lowest ground object's position dot y, then we want to set transform, which is our car's position, to respawn's position. If you think about this, it makes sense. It's again kind of wonky if you haven't gotten used to it yet. But we're comparing the y position of our car to the y position of the ground object we're going to feed it. And if we were below it, we're going to set the car's position to match the position of our respawn point. That does mean that now in the editor, when we click on car all, our script does want two more references. It wants the lowest ground object to be assigned, and it wants respawn position. Lowest ground object is just simply the ground. We'll drag ground onto it. Again, filling in that position that way. You could also have clicked on this thing if you want everything with a transform. Now respawn position we don't have yet. So let's create one. All we need for that is position in space. So go to game object, create empty, which gives us a coordinate with rotation but no other data associated with it. And let's just set it over here just for an example, because we'll know that it's, you know, it's a very particular spot here to the right of the camera, and it's not necessarily where the car started, but it's close, you know, it's a safe position. We'll call that respawn spot. You can name it whatever we like. This is just to stay organized. And now for car all, we will assign respawn spot to respawn position. And if we test our script, there we go. Car can drive off the edge of the world, and we can pick it back up with the X key. And so you can see there that the car is keeping the tumble from when it goes off the edge of the world. Another way that we can fix that, I guess the simplest way, is if we also set transform.rotation to the respawn position's rotation. And now it doesn't matter that the car was upside down when it fell, it will be the orientation of the respawn position. You'll see we're still spinning. So for that we could borrow code if we wanted from this X button to stop the car spinning and so on. Not terribly important to worry about, but if we want to see what that looks like, it's a more stable respawn system. And now what if we want the car to respawn exactly where the car started? I think that's a sensible expectation for the player. We want to put the respawn spot exactly on top of the car, and there's a very easy way to do this in Unity. So the position coordinates of a transform are relative to a parent. So if we make respawn spot temporarily a child of car all, and then we zero out its transform data, it will center it on the car. And we can also zero out its rotation to make sure it's the same orientation. It looks like we already are. And now we'll make respawn spot no longer a child of the car, so it won't move when the car does, and it recorrects the transform data to be world coordinates. So now, when we respawn, we'll respawn in exactly the same position as our car started in. And that's just a handy little trick in Unity to center one object's coordinates and orientation on another one. Let's create a tree trunk. Let's have a tree to crash into. And for that, we're going to go game object, create other. Let's make it out of a cylinder. That makes sense to me. You can see by default the cylinder isn't very tall. Let's make it taller. Maybe not that tall. Drag it up and down. Yeah, that's kind of a good height. Maybe a little bit skinnier. It's probably taller than it needs to be. And this is sort of as practice. Let's give it a new material. Assets, create material. What color instead of white? Tree trunk looking brown. I accidentally forgot to name it, so it says new material. Again, I'm going to use Enter on a Mac, F2 on Windows to rename that to tree trunk color. I'm going to drag that onto the tree trunk. And then we need a top of the tree. For that, I'm going to, let's rename this cylinder to trunk. Game object, create other sphere. Tree top. And let's make that grass colored because it's close enough to a tree. And it's kind of a little extreme. There we go. We got a nice little tree going right there. Now we could make trunk a child of treetop or treetop a child of trunk to stay organized. What I recommend instead is to create a completely new game object, create empty. Call this full tree. And we're going to make both the treetop and the trunk child of full tree. The reason for this is this allows us to keep the scale of the parent 1, 1, 1. If you make either one of these scaled objects a child of the other, scale can get messy when you start to do rotations of children and so on. So I prefer to create an empty and use that kind of as a folder like we showed earlier. So we have a tree now, and sure enough we can crash into it just like we always did. Bump. But let's make it so when you crash into the tree it respawns the car. And so the first thing we're going to need to do for that is create a new C# script. Create C# script, assets, create C# script. We're going to name that reset from crash. And then inside this script, reset from crash, we're not going to write any code for starter update. Instead, we are going to write code for a function called onCollisionEnter, which has one argument, collision, the collision. And this is code that gets called whenever a rigid body collision occurs. Car driver, other objects script equals the collision dot game object dot get component car driver parentheses semicolon. I realize this looks kind of alien. We'll walk through in a second how this works and what it's doing. And then if other object script does not equal to null, we're going to call other object script dot respawn. And now let's go back to car driver, which is the script we're pointing to. We're going to create a public function called respawn. In which, so here we have code already for how to respawn and update for when you go below the earth. Let's just change that to a call to this function, and we're going to move that code. I copy and pasted it from down there up to respawn. So now if we fall off the edge of the earth, it will respawn the car, meaning it will execute this code for the car. But also if we crash into the tree, because this function is public, we can call it on the other object that collided with us. And this is a really powerful way in Unity, or a powerful thing to be able to do in Unity, to get a script on the other object. So this is checking, does the other object that I have this collision with as the tree Does it have the car driver script attached? And if it does, or call the respawn function on that object. Now we're not quite out clear, unfortunately, because if we try this now, well, so first of all, we haven't attached it yet. So let's go to our full tree. Let's attach reset from crash. But again, we're not going to have any results yet, and this can be frustrating for Unity of why doesn't it respawn me yet. And the reason is the tree has to be a rigid body. Like I said, on collision enter is an event thrown when rigid bodies collide, but the tree is not. So let's go to component physics, rigid body. And so now we can collide with the tree and the car should respawn, and it does. I will say though that, oh, our tree fell over. That's a problem. The way we need to avoid that is to tell it that this tree is kinematic. We're going to check mark it. That's actually the same, I believe, as setting constraints, as turning on all 6 of these boxes to freeze position and rotation. And this just tells it, don't let physics code move this object. We just want to use this to detect collisions and things like that. And so now we collide with a tree, it respawns us in the same way that let's verify that driving off the edge still works too, and it does. Next up, we're going to cover briefly the prefab system, which is a powerful way in Unity to create sort of an exemplar object and the modifications of it. So let's go to Asset, Create Prefab. Over here we're going to name the prefab. I'm going to name it TreeFab because I think that's outstanding. Now we're going to drag full tree, the parent object, onto TreeFab. And now here's the magic. We can drag TreeFab onto the ground all over the place. Let's throw some trees around. And each one of these is already hooked up the same way as our first tree, with a rigid body and with the scripts attached and so on, so that when the car drives around and collides with them, it gets respawned in the middle. And even more interesting, so you can see that each have their own position, so the position data here is in bold. You can make changes to these, so I can make the scale of the treetop on this one, let's make it bigger. And then let's make this tree's trunk taller and thicker. 2, 2, 5, let's make this a huge tree. Treetop. 10, 10, 10. Yeah, so massive tree over here. And they'll all still act the same. You can see there's our huge tree. It respawns us, just like our lower, bigger top tree is. And we can take those changes, which you can see are highlighted in bold, and we can either be like, you know what, I didn't mean to make this tree so big, I want it to be exactly the way my default prefab is. If we click on revert, it will take it back to the properties of our common prefab object here under project. Or if we've made changes to one, like let's say I had turrets, and this actually happened in Freezing Solid recently. I had turrets and I made one of them play a little bit better by adjusting its tuning parameters, and I wanted all the turrets like that. So let's say that we decided this tree works better with what we're going for. We'll click on that one tree, and here under prefab options, instead of revert, if we click apply, it'll make all the prefabs catch up to the settings that were bold except position, and we'll take on those connections and qualities. Our sky is gray, which is kind of unfortunate, or I guess it's kind of a bluish. But we want to have control over the sky, and so let's create a new material, and we'll name that sky color. Change the color from white here to whatever shade of blue you like. There we go. There's a blue for the sky. Let's go to Edit. Render settings is where we can set the skybox. This is also where we could set up fog if we wanted it. And we're going to drag sky color onto skybox material. You can see there it instantly filled in, and now we have a color of our sky. You could use cube maps and other fancy things for this. We're not going to worry about that here. It's just give you some control over making it look a little less like the template. And again, fog, if you want to check it on and things and play with those values, you are more than welcome. Let's also add text. This is a very useful basic skill. Game object, create other GUI text. And it's going to, by default, appear in the middle of the screen. Let's set its position to 0, which is the left side, 1, which is the top, 0. And the reason why those are the edges is because the anchor is set to the upper left. We could change this to make it appear in another corner if we so pleased. Now let's set the text for it. I'm going to say car sample in Unity. What is it? I think Alt-Enter by Chris Delion. An Alt-Enter is the way that I go to a next line. It may be different in Windows, but there's probably some key combination with Enter to get a new line instead of completing the text box. And so now when we play the game, those words appear there, and so it's a good way to credit your work in case it gets lifted and shows up elsewhere on the internet, or to provide instructions or whatever your needs might be. And just like any of the other objects, you can connect this up to code to read out positional data and so on. So if we want to go to the car driver script, let's say we want public GUI text debug output, and we're going to hook up our text object to this. Inside update, let's say that we're really concerned with knowing the car's X position for whatever reason. Then we're just going to set the debug output. Actually, I'm going to make that a string. Empty string plus whatever, we'll make a string out of it trivially. So we're going to set the text property of our GUI text to the X position of the car. And then don't forget under car_all that we have to hook up debug output to our GUI text object. So from the hierarchy, there it is to our debug output. That's with car_all selected in the inspector. And now as I drive around, we can see that value. And so this, of course, is a handy way to provide arbitrarily complex or even spatially relevant data as you're working on debugging features of your game by showing text on the screen. One last thing that we also need to account for is we need to find code that we know will always be running. In our case, car driver seems pretty safe. But something to be careful of, right, is if the car got removed from the universe, say it exploded, this code would no longer run. We need to put what I'm about to show you in code that will always be running, which for this program we know is here. Let's do input.getKey keycode.escape. So if the user presses the escape key, then we're going to do application.quit. This will not show up in a web version. This will not work inside the Unity editor, but this is absolutely essential if you are doing a local Windows or Macintosh build, so that someone can quit your game without having to control it, delete, or force quit it. It's a little insane to me that this isn't built into the program, but developer be warned, add this to your program. It will save you trouble and save your user frustration. So again, escape key will do nothing here, but when we export the program now, we can use escape to quit, which will be very handy. That's it for now, except for making a build. So let's go to File, Build Settings, and this is, of course, where Unity shines. Here we can tell it we want a Mac OS X build, and click Build, and it'll let us choose where we want to put it. I like to create a folder called Deploy inside my project and save all my outputs there. Car Mac. Get it? It'll take it a second to output the project information. And it'll show us the version, and I can now run that. It by default lets me choose my properties. Let's play it windowed. It's going to be my full screen. And there's my game. I can drive around, I can re-rent the car, go off the edge of the earth. Everything still works. My trees, of course, I updated the prefab like we showed. I'm still getting the debug text output. And if I press escape, it'll close that since we added that important code. You can also output the PC, the Windows build, even on Mac. Again, I like to put it in my deploy folder. Car PC, that one's less of a pun on a famous game designer's name. Take it a moment. And then the other thing we can do is we can output for web player. All of these, of course, are free. With Unity, you have to pay for the other output options. Don't worry about those for now. Deploy car web. And when you output for web, it'll give you an HTML file with the file already embedded. Car Unity, car HTML. And so this is actually all that I had to do to output the sample build that I showed at the start of this walkthrough, was just outputting the build this way and posting that HTML file to the web. And again, everything works. Escape key is ignored harmlessly. And I hope you've had a good time following this tutorial. I know it's not beautiful, but hopefully it's enough to get some people started in exploring Unity and all the great things you can do with it. If you've got questions, please let me know. I'd be happy to answer them. I might do a follow-up video showing sound, some various other kind of hookups, camera techniques, if folks are interested. If you want the full source code, check it out. It's going to be on a blog entry at HobbyGameDev.com. Thanks again, and have a good time with it. Bye-bye.